Okay, we're going to go over our first chemistry notes. So most of this is going to be a review from what you learned in the simulation. And it's kind of just going to sum it up. Okay, you can take notes. It's up to you. You can also complete the classwork while you watch this. Okay, so when we're looking at the atom is the basic building block of all matter. In other words, matter is anything that's going to take up space in the universe. When we're looking at the atom, think about atom as the simplest type of compound that you can have, or rather form of matter that you can have. If you're breaking something down, you can't break it down to further than an atom. Okay, the atom is going to have three main components. We have our protons and our neutrons, which are in the nucleus. Some of you guys said the center. We got to be specific. It's called the nucleus. Then we have electrons, which orbit around it. Okay, so when we're dealing with these type of particles, they have extremely small masses. So for example, let's say, let me make this a little bit smaller. Let's say we have one proton. One proton would have a mass something like 0, 0, 0, 0, and these zeros will continue for like 16 until we eventually get to a 1. So this is an extreme, it'll be something like grams, right? So this is an extremely small amount of mass, and scientists don't want to deal with this kind of like that amount of those. They don't want to deal with such small numbers. So in order to work around that, scientists have made up their own unit to measure very small mass. Okay, the unit that they made up is the atomic mass unit. So the atomic mass unit is equal to 1 proton or 1 neutron. Okay, it's just an easier way to say a proton equals 1 atomic mass unit rather than having to put this very large number. Okay, so just keep that in mind. 1 atomic mass unit is just a way that we use to measure very small atomic things. Okay, let's erase this and go on to the next part. Okay, so going on to the next slide, so we have the nucleus. So you should have seen in the simulation that the nucleus contains our protons and it contains our neutrons. Okay, so my nucleus, it has a positive charge. Why does it have a positive charge? Well, protons have if we think about it, protons have a positive charge. Neutrons have no charge. They have a 0. Well, what's positive plus 0? For example, positive 1 plus 0, that's going to be positive. So because this is positives and 0 charges, this overall, the center of this is considered to be positively charged overall. Okay. All right, then we have the protons. This is important because this determines the type of element I have. Okay, so this has a mass of 1. It's located in the nucleus, has a positive charge. So again, this determines my element. For example, if I have 1 proton, it's always going to be hydrogen, no matter what. If I have 2 protons, it's always going to be helium. So the protons determine the element, and not anything else, not the neutrons, not the electrons. Okay. Then we have the neutrons. The neutrons help stabilize the nucleus and prevent it from breaking apart. If something's unstable and it breaks apart, what happens is they end up releasing electromagnetic waves, right? We've gone over that. They break apart, they release electromagnetic waves, and those electromagnetic waves can be harmful, such as gamma rays, and just other forms of radiation. So the most important thing to remember is that neutrons stabilize the nucleus. Things that are unstable are things that we consider to be radioactive. So radioactive compounds are very unstable. They don't have the correct number of neutrons. And they usually break up to become more stable compounds. Okay. All right, so they also have a mass of 1, and they're also located in the nucleus. Okay. There's a word that I want to bring up here because it might come up a couple times. Okay, so this is the concept of an isotope. So an isotope is a compound which has the same number of protons but different number of neutrons. Okay, so let's think about that. If I have the same number of protons, then I have to be the same element because the protons determine my element. Well, in this case, I have 12 protons. I have 6 protons, 6 protons, 6 protons. Therefore, all of these are carbon. However, they all have different amount of neutrons. Neutrons is our blue one. So neutrons is this. This has 8 neutrons. This has 7 neutrons. And then this one has 6 neutrons. So because it has a different number of neutrons, they're going to have different masses. They're different forms of carbon. Some are stable, some are not. Okay, that's what we call an isotope. All of these are isotopes of carbon. Same compound, but different neutrons. Okay, so isotopes are the same compound, same element, but different neutrons. Okay, so this is just, then we have, actually the last one we have is electrons. So electrons are going to be negatively charged. They are not in the nucleus. They are extremely small, about 100 times smaller than the proton or a neutron. So this is the size, rather, or the mass. It's 1 over almost 2,000 atomic mass units. Because this is so small, we can actually consider this to be a mass of, if you put this in the calculator, you're going to get something like 0.000. So we can just consider this to be 0. Okay, when we're thinking about protons, we just say they have a mass of 0 atomic mass units. They're so small that we don't even take them into consideration. Okay, so electrons can be found in what we call energy shells or orbitals. They're the same thing, they're just different models, different ways of looking at it. And we pick the model that best suits what we're trying to study. Okay, so this is these are orbitals here. So electrons are constantly moving in orbitals, constantly moving, constantly moving. Same thing here, constantly moving. So in reality, electrons are in what we call orbitals. But in order to kind of understand elements better, we tend to place them in what we call energy shells because it's easier to look at them and it's easier to study their behavior. Okay, so we can say that electrons hang out in energy shells, or we can say they hang out in orbitals. They're the same thing, they're just different ways of looking at it. Okay, so neither one is correct and neither one is wrong. And we'll go into energy shells in a little bit more detail in our next lesson. Okay, this is just a so the next slide is just a summary. Protons, neutrons, electrons. These have masses. This has basically a mass of 0. Protons positive. How to remember that? Well, there's a P in there, right? P positive. Neutrons, 0. Another way of saying 0 is neutral. So neutral, neutron, very similar. Okay, electrons are negative. Both of these are in the nucleus, whereas the electrons are in shells or energy levels, or you can also say orbitals. Okay, all right, let's go over some distinctions that are going to come up. So what is a compound? Well, a compound is when we have 2 or more chemical elements bonded together. Okay, typically it's 2 or more different compounds. Okay, so not the same. So for example, here I have nitrogen bonded to oxygen. That's 2 different compounds. Then we have CO2. We have 1 carbon molecule, which is carbon is green here, right? Bonded to 2 oxygen molecules. So they're different atoms because we have carbon atoms and oxygen atoms. In this example, we have nitrogen atoms bonded to an oxygen atom. So they are different atoms. Okay. So that's usually, typically when you see a compound, that's what they're referring to. We also have molecules, which are slightly different. Okay. Molecules are 2 or more chemically bonded atoms. This can be the same or it can be different atoms. So this is kind of the big difference here, that they can be the same. So for example, let's say I have an oxygen molecule bonded to another oxygen molecule. We'll do a double bond, we'll go over that later, right? This is a molecule because it's the same, but we have more than one. Okay, for example, I can have, let's say I have a hydrogen molecule. I have a hydrogen molecule bonded to another hydrogen molecule. You can think about this. Think about it as having a circle around it. Either way, right? 2 hydrogen molecules. We have 2 or more, and they're the same. So all of these are real molecules. They're the same, but they can also be different. So for example, I can have a hydrogen bonded to an oxygen, bonded to another hydrogen, in other words, H2O. So this is considered a molecule, a water molecule. It can also be considered a compound though. So things can be compounds and molecules, but they can't. If they're made of the same thing, they have to be a molecule. They're not a compound. Okay, compounds are always different things bonded. Okay, let's go over the last concept here. So we went over compounds here. Compounds, molecules. Last of all, we have pure substances and mixtures. Okay, so a pure substance is when we have the same type of matter. In other words, things are not chemically bonded to each other. So for example, let's say these are compound element X. Okay, we'll just make up a name for element X. All of this is element X, so that's a pure substance. Okay, but we can also have a compound and still be a pure substance because they're chemically bonded. Okay, for example, let's say I have X, compound X, bonded to chemical Y. Okay, so they're one molecule, right? They're one molecule. They're not separated. So, but we have a bunch of these next to each other. So we have a bunch of these compounds next to each other. That is what I call that's still a pure substance because I still have only one type of molecule. Okay, so things have to be chemically bonded. That is a pure substance. Now let's look at mixtures. If we compare these, this and this, they look very similar, but these compounds are not bonded. In other words, I have X by itself, and then I have some Y in there floating as well. So I have Y and X. They're not bonded together. They're just freely. They're just mixed together. Okay. So let's look at mixtures a little bit more closely. So if I have a mixture is going to contain two or more substances that are not chemically bonded. Okay, so not chemically bonded. That's the important part. Okay. So for example, this is one type of element. So what would this be? Well, that would be a pure substance. It's only one type of element. Here we have multiple elements, but it's still the same, right? So even though they're molecules, it's still the same type of molecule. So that's still a pure substance. This one here is a little tricky. We have these big molecules. Is that a mixture or is that a pure substance? Well, when you look at it, this is one compound and this one is exactly the same as this one, right? They're the same thing. So they're not, and they're chemically bonded. So because they're chemically bonded, that's going to be a pure substance. However, if we look at this one, well, this is different than this, right? They're not chemically bonded. This is different than that. This is a mixture of elements and compounds. Okay, so this is a mixture. This looks like it could be a mixture, but that is a pure substance. Okay, if you have any questions, just let me know. Email me and I'll get back to you guys as soon as I can.